Assalamu alaikum wa rahmatullah. We know that redox reactions are the reactions that involve a transfer of electrons from one species into another. Dear students, after this period you should be able to balance equation of redox reaction. So our objective is balancing redox reactions using half reactions method in acidic medium. Let's consider the simple redox reaction between Fe iron solid and Cu2 plus aqueous that is represented by the equation. Fe plus Cu2 plus gives Fe2 plus Cu. In this reaction, the species Fe loses 2 electrons and undergoes oxidation, where Cu2 plus species gains 2 electrons and undergoes a reduction. Such reactions are considered to be simple with respect to their balancing. Such reactions can be balanced simply by balancing the electrical charge by adding electrons and coefficients if necessary. But redox reactions can become more complicated if molecules of solvent are involved in chemical reactions as water molecules in aqueous solution. Let's learn how to balance this kind of redox reactions now using half reactions method in an acidic medium. The half reactions are oxidation half reaction and reduction half reaction. For example, in aqueous solution, the dichromate ion reacts with iron 2 or ferrous to give chromium 3 and iron 3 ions or ferric ions. Now, how do we proceed? So, how do we proceed to balance this equation? Dear students, you have to follow the steps. Step 1, split up into half reactions. So we have to split the reaction into two half reactions, the oxidation half reaction and reduction half reaction. Oxidation half reaction where Fe2 plus is transformed into Fe3 plus, where reduction half reaction is the transformation of Cr2O7 2 minus into Cr3 plus. Step 2, balance elements other than hydrogen and oxygen. Now we must balance each half reaction starting with elements other than hydrogen and oxygen. We can see that for the reduction we need to put 2 in front of Cr3 plus. Two in red in front of Cr3 plus to get 2 chromium atoms on each side. Then step 3, balance oxygen with water molecules by adding water molecules wherever needed. For reduction half reaction, we have 7 oxygen atoms on the left hand side. So we add 7 water molecules on the left hand side to balance the oxygen atoms. Now, let's move to step 4, where we have to balance the hydrogen atoms with hydrogen ions or adding hydrogen ions wherever needed. Since there are 14 hydrogen atoms on the right hand side of the reduction half reaction, then we have to add 14 hydrogen ions H+ on the right hand side of the half reaction. Then this means all the elements are balanced. Here, Cr2O7 2 minus plus 14H plus gives 2Cr3 plus 7H2O. All the elements in the half reaction are now being balanced. Let's move to step 5, where we have to balance charge with electrons or adding electrons wherever needed. In the oxidation half reaction, in order for iron 2 to become iron 3, it must lose an electron, so there must be one electron as a product. Now Fe2 gives Fe3 plus 1 electron. As for the reduction, it's a little trickier. We have 2 on the dichromate, 2 minus on the dichromate, add 14 pluses for a total 12 plus on the left. On the right, we have 2 chromium, 3 ions for a total of 6 plus. In order to balance this, we need 6 electrons on the left to bring the charge down to 6 plus and balance the charge. Then it becomes Cr2O7 2 minus plus 14H plus 6 electrons to give 2Cr3 plus 7H2O. Step 6, make the electron numbers equal. How? By multiplying by a coefficient or by a okay, then to balance the charge, to equalize the number of electrons in both half reactions, we have to multiply whatever needed by a constant. So the oxidation half reaction should be multiplied by 6. It becomes 6 Fe2 plus to give 6 Fe3 plus 6 electrons. And the reduction half reaction, we have 6 electrons on the left hand side. Step 7, we have to combine the two half reactions together. Because the number of electrons becomes equal, we can combine the two half reactions together. Then we have to cancel the same species from both sides of the reaction. In our case, we have only 6 electrons on each side of the reaction. So this should be cancelled. After that, the reaction becomes 6 Fe2 plus Cr2O7 2 minus plus 14H plus to give 2 Cr3 plus 7H2O plus 6 Fe3 plus. Now, the equation of the redox reaction becomes balanced under acidic medium. And this is indicated by the presence of H plus in the reactant side. Dear students, now you have to apply these steps in order to balance any redox reaction by using half reactions method in acidic medium. Step 1, split into half reactions, oxidation and reduction half reactions. Then balance elements besides O and H. 3. Balance oxygen by adding water molecules wherever needed. 4. Balance hydrogen atoms by adding hydrogen ion wherever needed. 5. Balance charge with electrons. Match numbers of electrons or equalize the number of electrons in the oxidation half reaction and the reduction half reaction. 7. Combine the half reactions. Finally, please, students, try to balance the following equation. Cr2O7 2 minus plus HNO2 to give Cr3 plus NO3 minus. Dear students, thanks for your kind attention. Thank you.